It's Christmas Eve, you're just a little kid waiting for Santa to bring your favorite toy. An aftermarket standalone ECU Link G4X for the Skyline R33 GTST with the RB25 VET Neo. Then suddenly you wake up, you're an adult, and you're sick of waiting for Santa, so you bought it yourself. Yeah, I know, it's not Christmas anymore, but hey, I shot this video during Christmas, so that's it. Enjoy the video. So that's it. Now what we're going to be doing in this video is we're going to install it on our Skyline. Finally, as you know, we did all the mechanical side of the car. So we did exhaust, we did the turbo. We did the intake manifold. So now we're only missing the ECU. We're gonna set up the sensors. No, we need to remove the old ECU from the case and put the new ECU in the old case. That's how the Link ECU plug and play works. You already know the sensors, guys. We did it in the last videos. We did the EIT sensor. We have the NOx sensors, the two NOx sensors. We have the oil pressure and oil temperature sensor, which is the same connector. It's the same sensor, but it does temperature and pressure. I see the EGT also and the AFR. We're going to connect all those sensors into the ECU, into this ECU. And yeah, after that, we will tune the car and see, hopefully we'll reach those 500 famous horsepower. Let's go. So guys, we have everything we need here. We have the stock ECU. Then we have the Link ECU, of course. Hell yeah.
Yeah!
Then we have the expansion loom for all the sensors, you know. Then we have the CAN cable, so we can also connect it to the radio, so we can check all the parameters in real time without the computer. And then we have the hose for the map sensor. Here we're going to connect the expansion loom. Here we're going to connect the CAN line. And then here we have the connector for the computer. And here we have the map sensor. Guys, we finished preparing the ECU, mounting it on the stock case. Oh, we used some zip ties to fix it, so they won't go back and forth, you know. And then we will mount it on the car and find the right setup to make it turn on. The ECU is fixed in its position. Now we also passed the map cable, the map hose, as you can see. The expansion loom. The cables come out from there. The map hose as well goes into the filter and into the intake. Now we have all the cables from the expansion loom, which we're going to connect all the sensors to. Oh, by the way, we also are going to change these cables because they're not okay for the NOx sensors. So we bought the right cable for the NOx sensors, which is a coaxial cable. It's protected from other outside signals. Like if you have injectors that pass nearby these cables, they are just going to ignore completely everything that's outside of this cable. And the signal is going to be perfect. So right now we'll need to connect all the sensors, connect them all to the ECU. Now let's do that, and then we can continue with configuring everything inside the Link software. I'm going to show you the diagram so you can see it. So attached the EAT to the expansion loom, yeah. So it's two cables that go into the expansion loom, another 5 cables that go to the oil pressure and oil temperature sensor. We also did the boost controller that we attached right here, that we connected to the stock, let's say, cables. We only modified the connector. As you can see, the connector is not the stock one. As you can see, this is the EGT. We brought it inside towards the EGT board that I'm going to show you right away. So we have the EGT board right here. So basically how this works, it takes the signal from the normal EGT that you find on normal cars, changes it into a signal that's readable by the Link ECU, because the ECU can only read from 0 to 5 volts. I'm going to put a radio in here so that we will have all the gauges right there on the radio. Okay, the last thing that we're missing here is this is the CAN signal from the AFR. So basically we decided to use one of the CAN connectors and to connect it to the AFR. So that way the signal should be even more precise than the normal sensors if we were to attach it directly to an AN volt or something like that. So yeah, now that we know everything about how I connected all the sensors, it's now time to configure all the sensors inside the Link app on the computer. So let's take the computer, let's attach it, and let's see how to calibrate those sensors. Let's go. So guys, we got the laptop right here. So first things we're going to be doing is we're going to load up the base map. So let's go into File, Open. We go into the Link G5 directory. Then we go into the sample maps. We choose our engine, our car. So we have the R32, we have the R32, we have the R32 and R33 GTS 7 bar, which is our version. We have the G4X plugin, we have the R33 GTS, and yeah, we have the G4X with the 7 bar map sensor included in. So yeah, let's load up this map. Yes, I don't know what this is, but okay. We're not responding, huh? Okay, sure. Okay, we uploaded the map, we loaded it into the ECU. Now let's see if she's gonna start right now. Come on, baby. Let's try again.
The next day.
Guys, it's another day. We're trying to turn it on again. Yesterday the problem was that the AFR was too rich, so the car was getting the engine was flooded. So yeah, the spark plugs were I think they were wet because of too much fuel. Yeah, I could smell the fuel from inside the engine bay. So hopefully it shouldn't be. And the battery was dying, so we charged the battery. We waited for the spark plugs to get dry, and now let's try again. Let's see AFR. Okay, it looks okay. The good thing is that it's turning on, and yeah, right now we'll try to accelerate, and I'll show you guys how it's she's turning off because of accelerating. She becomes super lean. See, she tends to die. So I still need to figure that out. We'll try and configure all the sensors that we attached, and then we'll come back with more information. Now, let's go. After 3 days of freaking going insane, we managed to make this little tiny thing work. Now, what do I mean by that? Well, basically, this is a new cam position sensor for whoever doesn't know that. We swapped out the old one, which was garbage. It's not precise, it's not so reliable, so we switched on with the new one, last generation, blah 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 blah, whatever you want to call it. But we were having a lot of issues because we didn't understand each one of these pins. Where do they actually freaking go? R32 and R33, they all have the same cast. R34 has a different cast, so the pinout changes. At the same time, I find out that my head of the engine is actually a RB25DE without the T, which means no turbo, Neo. So that means it's from a R34 GT without the turbo. So yeah, only the head. I think the block is something different. I think the block is just the old one. I'm not sure, but don't mind that. Anyway, we were talking about the the trigger kit. Okay, so basically we went insane for 3 days because of this trigger kit. Now, the final configuration that for us worked is basically this. First of all, we need to not have anything that can, I don't know, how can I say this? Like anything that can make thickness, you know, in between, this is thickness, you know, you see that? This right here, this one adds thickness to this distance that we have between here and the tiny little wheel that we installed right underneath there, which I was supposed to show you, but sorry guys about that, I'll just show you a picture up here. So we install it in, we try to install it just as it was, and this one was making thickness, and we were not able to read the sensor properly. So once we solved that, we went as close as we could to with the sensor to the wheel, to the trigger wheel. So as you can see, we have one pin there in the middle and another one on the edge, let's say, on the outside of the sensor. So basically we figured that, in my case at least, I think in most RB25 cases, if they're not GTR, I need to make sure that I don't remember very well. Yeah, I think in the GTST, this is the right setup. If you have GTR or something else, just make sure this is the right setup for you. Otherwise, change the pins. Change the pins and change the trigger that comes into them. So make sure you have the trigger one in the middle of the pin, and the external one, you need to have the ground. The blue, yellow one is the 41. Then we have 42, the blue one. Then underneath we have again 51, the green one, and as you can see, there's the empty spot on 52. So trigger 2 stands on the pin 41 and 51, as you can see, blue, yellow, and green. And we have the pin 52 and 42, the blue one, and 52, which is underneath, which is empty. We only used the 52, which in our case was trigger 1, because the other one was trigger 2. So we connected ourselves basically to the 52 pin, to the ground pin of the car, which is not, so let's say it's not the best, but if it works for you guys, just keep it that way. Maybe take a look at the scope inside maybe take a look at the trigger scope inside the PC Link management. So I'll show you guys right here. So let's start by trigger setup. Okay guys, you need to choose multi-tooth missing, and the RPM filtering, just leave it as it is. In trigger 1, you need to make sure you put reluctor level 1 low, cam, tooth count 24, in my case is 24 and 1 missing teeth, number of gaps 1, sync tooth 1. Trigger arming threshold table, guys, this is also important. Make sure you have 002 here on our case, because the signal on the scope is basically it starts from 0.2, but at cranking it's very low because it's spinning very low. Okay, so it creates really low voltage. And yeah, remember to put this 02, and it should be able to read your scope. Okay, trigger 2, basically we're not using it, so we just we're just putting reluctor level 1 low, and then we sync mode none, leave it as it is. Basically I'll just show you a quick scope for you guys. Basically, as I was saying, you guys should have this kind of signal inside the DI, which I don't know what, I have no idea what it stands for. Trigger state should be something like this. But yeah, at this point she's reading a high voltage. Only, you see, we have 2.94 volts, but during the cranking we had like 0.2. Once the car turns on, this number gets much higher. So yeah, if you have this kind of scope, this kind of signal, this is the signal that you, as I told you, that you're going to have once the car is turned on. I went into the PC Link setup for the base timing, and I'm going to show you what I did in there. But before, I want to explain what I did in here inside the engine. So basically, we put the timing light. As you can see, you know how this works. Whenever there's a spark into the first cylinder, this one it makes a light, so that you can see exactly where at which point the first spark is happening. So basically, on these engines, mostly it's 10 degrees before top dead center. So we have multiple. Come here, man, cameraman. As you can see, we have those tiny marks on the crank pulley. You see them? See those timing marks? Basically, from left to right, we have 0 degrees, 5, 10, 15, 20, 25, and 30 degrees before top dead center. We have those references. so we can check if the base timing is right. So we can check that the spark, the first spark on the first plug is right where the ECU think is right. So basically we are seeing that the engine is at, I don't know, let's say 10 degrees before top dead center, as these engines usually are. So we are telling the ECU, okay, when here we have 10 degrees, so when we are on the third line of the crank pulley, we need to also see on the ECU that she's seeing that we are also on the 10 degrees before top dead center point. So that we know that she knows exactly in which position the cam and the crankshaft. I'll show you the setup that I did inside the ECU. So basically, as I told you, we are telling the ECU that our reference timing is 10 degrees, you know, because as I told you, we have the third line on the crank pulley, which equals 10 degrees. After that, when we have the engine on, we check with the timing light. If this one matches with 10 degrees, while we have this window open, it means that it's firing the spark plug exactly in the right moment. We were having 98 here, so basically we were seeing 10 here, but we were seeing 15 on the engine. And so we went back until 93 to tell her that we were 5 degrees over the before top dead center for us. So we were 15 instead of 10. So from 93, from 98 that we had here, we put 93. So that from 15 she went to 10 degrees before top dead center, and now she's fully precise and ready to go. Hey, look, my fan is here. You like it?
Yeah, I like it.
Guys, so sorry, I dropped my fan. My fan has arrived. Finally, I decided to switch to an electric fan, as you can see, because of two reasons. First of all, this engine was not operating to the right temperature. So basically, I don't know if you guys have the same problem, but for me, especially during winter, this engine always stays too cold, and it's like, I don't know, it stays up to 60, 70 degrees. It's not going to get hot inside the cabin, so that's the first problem. Second problem, if you need to do a map, so if you need to tune the car, as we're going to be doing today, I mean not today, but we're going to be doing in the future, we need to have the engine at the same operating temperature when you do the map. So, because if you don't, the AFR is going to act differently, because your engine is going to be cooler or hotter. So if you don't have the engine at 90 degrees Celsius, of course, which is its perfect operating temperature, you shouldn't do a map. Because if you do, I don't know, let's say you do a map at 70 degrees, okay, and then you try to make a pull at 90 degrees, the AFR is going to be different. These are the two main problems that made me go and chose an electric fan. We're going into the ECU, we're gonna attach ourselves to our second expansion loom and only attach one cable. We're gonna give the command from the ECU to the fan, sorry, not directly to the fan, but through a relay. And we're going to give the command from the ECU to the relay that's going to activate and give power to the electric fan. Now I'm going to show you the diagram that I have right here. And yeah, we're going to wire it up exactly as you see in this diagram. Ta-ta.
Spinny boy.
Spinning. You spin my world. You spin my fan. And that's it. You just spin my fan. Let's go work, man. We need to work. Let's go. We need to map this car.
Yeah.
Come on, let's go. So guys, there we have it. The job is completed. Now I want to explain to you everything that I did. So here we have the relay. As you can see, we managed to put it in the stock, let's say, relay area of the car. So, sorry, on the stock relay box. So that's pretty freaking cool. And yeah, we have the 4 wires, as you can see. One is attached to the positive pole of the battery with a 20 with the 20 amp fuse in the middle. Then from there it goes to the positive of the fan, and the negative is attached here. Then we have the other 2 cables that are the switch that's going to be manipulated by the ECU, and this one goes inside the aux 11 on the ECU on the expansion loom number 2. It's inside, so yeah, I'm not going to open it again. It's pretty simple. And we have the other side that goes to the plus for the battery. Okay, updated. We found a good relay. The Amazon is today has betrayed us. They told us they were gonna come today, but they didn't. So yeah, f you, Jeff Bezos. He lied to us. Jeff, you lied to us, Mr. Jeff. How dare you? But yeah, fortunately we had one inside the workshop. We had to sacrifice the middle pin, but this one's working, so let's check it out. Okay. Oh! Oh yes! Can you hear her? She's spinning! Woohoo! Funzionale! Bellissimo! Boy! Nice! So yeah, now we're missing only the NOx sensors. Let's set them up and then we can finally tune this car, man, on the street. Let's go! Okay guys, so I'm going to show you every setup that I did. So I already told you about the trigger. I already told you how to set up the fan. And now I'm going to show you first the fuel, because I changed the fuel setup. So here we inserted this mode, sequential mode. We have the CC of the car, of the engine, the fuel pressure. This one should be pretty standard. You shouldn't touch too much stuff around here. So in my case, I have the Bosch 731 cc's. So what else? Oh yeah, you need to also choose the dead time of your injectors. We have all our analog inputs, the EAT sensor, which is the one that I showed you before. This is the setup that I did for my sensor, for my EAT sensor. So you can just copy and paste this. Remember, you need to see where you connected it physically on the expansion loom, okay? So in my case it's AN temp 4. You should also create a calibration table. So in my case, I created a calibration table that I called EAT. It's in ohms, the input units, and the output units is in temperature. And this is the calibration table right here. As you can see, we have the EGT also. The EGT works in the same way that I showed you for the EAT. I had to configure my EGT inside my my GP inputs, and I choose the GP temperature because in my case I chose to use the AN Volt 8 as a temperature input. So in my case it's GP temperature 1, EGT. So I called it EGT. I inserted all the values. I gave it the right calibration table. Okay, this is also the same as before. This time the unit is not in ohms, this time is volts. Output unit is the same. This usually works for most EGT type K sensors. So if you copy and paste this configuration, you should be able to configure your sensors properly. Oil pressure and oil temperature. This one should be pretty easy. Fortunately, Link already has the, let's say, the calibration table already inserted. So you just need to select this Bosch 10 bar sensor, which has this code in here. If you're using the same one that I'm using, which also it's doing oil pressure and oil temperature, as you remember. So we have it on AN Volt 2 right here. Just copy and paste what I did here if you have the same sensors, and it should be working fine and properly. This one works for the oil pressure as well as the oil temperature. So it's the same sensor. You just need to insert Bosch NTC 0.261 and so on. Just copy and paste the same things. Just make sure you have the same source as I do. Let's change the source for your own case. So guys, I decided to connect the AFR. So if you choose to connect the AFR via CAN, you need to set it up properly inside the ECU link. So you need to go to CAN setup. You need to go into mode CAN 1. Just use this, just copy and paste exactly how I'm doing it here. So remember, set it up to CAN 1 because I have it connected to CAN 1. Choose user defined, choose 500 kilobits per second, sorry, kilobits per second. Leave this off. Then in channel, go to receive user stream 1, insert receive user stream 1, use the extended format and insert 384 inside this field here. You go to streams, stream 1, then load the stream. In our case is the AM X series Wego Gauge receive. Press open, it will, I'm not going to press it because I already did it. So it will become something like this, frame 1, lambda 1, and it should take automatically the values. Just press apply, then press OK, and it should be working properly. You should have your lambda right here as I do. I'm going to show you. Okay, now we're online. As you can see, 14.7 we have there, 14.5, same as here, so that's awesome, guys. That's awesome. Let me turn that off for you. So in lock setup, you just need to choose normalized ignition. In my case, I showed you already the sensor that I have. It's Bosch sensor, so you just use 4 to 10 kilohertz wideband. Just copy these exactly as you see them, and you should have your knock almost set up. In fuel ignition here, just leave this as it is for now. Maybe we're going to talk about that later in the next video. And yeah, you must have one. Oh yeah, you need to have, for every cylinder setup, you need to have one knock trim table. So for cylinder 1, I have knock trim table 1, cylinder 2, knock trim table 2, and so on. And then you go inside the logging and you add them all here, okay? You add all the parameters here, knock tables, one level, and so on. Okay guys, I'm going to show you a quick log of my knock while it's getting started. Let's see. Okay, I'm going to explain to you real quick. Let me turn this off. You should have something like this in your log, okay? How you're going to recognize your knock? Basically, when you have a real knock, you will see one of these spikes. Each one of these spikes represents one cylinder. You will see that it will go like super high, and the others are going to stay normal, or even some others are going to join it. Once you see those real spikes, that means that you right there you just had a knock, okay? The thing that I need to explain to you last is how do you adjust these numbers. You see here I have 120 here and I have 85 here. Okay, so if you see that one of the cylinders is always higher than the others, it means you need to lower the gain on that cylinder. So in my case, let's say we have knock table 4 pretty high, so I'm going to change the knock table 4 gain. I'm going to lower it maybe to, I don't know, 0.65 because it was 0.70. okay, in this way, whenever you accelerate, the knock table on the 4th cylinder should be a bit lower because you lowered the gain. Remember to do this game until you have these signals as equal as you can. Once you do that, you can take the car on the street, keep an eye on the knock, and an eye on every other sensors as I did here. So I have my AFR right here. You see also I have the target here, which I'm going to explain in the next video. We have the EAT, we have the oil pressure, oil temperature, AGT, and ECT. I think these are the most important values to keep an eye on while you do your maps. Maybe I'm going to show you. Oh yeah, oh, this is something different. Oh, never mind. It means you're not going to find it out now. You're going to find it out in the next video. So yeah, I'm just going to show you something very beautiful once the engine warms up. Just 1 second.
A few moments later.
Guys, you need some hair. Oh, okay, there you go. Okay guys, this is just one taste of what this ECU is able to do. So it's insane. It's freaking insane, guys. We already touched the fuel table a bit. So yeah, this is let's say the beginning result, not the end result, but the beginning result of what this ECU is capable of doing, guys. So, well, nothing else to say. In this video ends here because I told you guys so many things. If you have any doubts or any questions, just leave them down in the comments. I'll try to help you guys out. I hope you guys enjoyed the video. Stay tuned because in the next videos, this car is finally we're gonna be able to pull this car, to push this car to its limits. Anyway, you know, you guys just sfruttare il suo potenziale is our next goal. So yeah, I'll see you guys in the next video. Stay tuned. Boop.